Hello, students of geometry. Welcome to the Chapter 9 review on circles. If you're one of my students, spring 2020, with the coronavirus and all that's gone on in school, physical school closing, or one of the other students at the same school I'm working at, this I hope will be a really helpful video in terms of helping you refresh your mind on what was on that Chapter 9 review, what's to come on the Chapter 9 test. If you're just one of my students, so to speak, on YouTube, and then you're just trying to work on getting better at this stuff, hope you find this helpful as well. So let's jump right into it. At this point, we are matching for the first 10. Use circle O to name the following parts. We're going to put a capital letter, the correct answer, on the line next to it here. None of the choices are going to be used more than once. So if we look at AC, look at all these things, we're looking for the best descriptor of those things in this column. So AC, from here to here, it looks like it's a segment that connects 2 points on the circle, but it also goes through the center of the circle. So that's a chord, but it's a special type of chord known as a diameter. So choice B, diameter, we can cross that one off and keep going from there. So line CD, so the line keeps going this way and this way. It's a line that's cutting through 2 points of the circle, and we call that a secant. So that is choice F. Segment AD, this also connects 2 points on the circle as AC did, but it's not going through the center, so that is a more general thing that's called a chord. So again, this AC was a chord, but it's a special type of chord called a diameter. The best choice is diameter in that case. Angle AOB right here, it's an angle that contains the center of the circle. Its vertex is at the center of the circle. We call those central angles. So AOB would be choice D. And then angle CAD, right here, C to A to E to D, the vertex of that angle lies on the circle. That was called an inscribed angle. So that's choice C right there. Moving on to, this is the symbol for arc. So arc ADC, from here to here to here, following along the circle that way. That looks like we have half of the circle from there. This is a diameter A to C. So half the circle, 180, that's called a semicircle for number 6, choice J. Ray AE, Ray AE right here, that's something that just touches the circle at one point. If you called it line AE, it would be the same thing. It's going to be a tangent on this one. So choice G is a tangent. Arc BC, and it's only 2 letters, so we're going the shortest way possible from B to C, not the long way around, but the shortest way around. That looks like a minor arc for that one. So choice H, minor arc. OA, from here, from the center of the circle to a point on the circle, that's always a radius when we connect a point on the center of the circle to any point on the circle. And then major arc, hopefully that will be matching up with what we have here, B through D, and then to C, the long way around that connects B to C through D. That is indeed a major arc, more than 180 degrees for major, less than 180 degrees for minor arc. Moving on to problems, I was going to say choices, problems 11 through 18 then, the rest on our page 1 if you're one of my students in class. The measure of UTS, we could put an angle symbol in there. I feel like there should be angle symbols in 11, 12, and 13, but sorry, they're just not there on this for whatever reason. So UTS, sorry I missed that. From here to here, it looks like we could figure out, and this one I think I'm going to do some side work first before I address these any further. Let's figure what this one is, and it's pretty simple or straightforward to figure out what this one is. If you ever have a straight line, and this is 90 degrees, that's a safe assumption right here. You can make that this is also going to be a right angle. 180 minus 90 gives you 90. And then from here, we also are looking at this part here, also a straight line. That means these would all add up to 180, or since this is 90, you could assume that this is 90 right here. And so that means this angle right here would be 50 degrees because that's 90 minus 40. So some work there. You could do 180 minus 90 minus 40 and get 50 as well. You could do it that way. So the measure of UTS, angle UTS, is going to be 50 plus 40, which ends up being 90 degrees. And And then the measure of PQS, that arc, or that angle, rather, so P is Q to S. Yeah, this really should be saying, I think this was an arc. I don't think it was an arc. It was supposed to be an arc. That's just not showing up on my copy here. So the measure of UTS, PQS, and PRU, all of those things should have the arc symbols over it. So the angle, central angle, is going to match up with the arc. So from U to T to S, connecting those this way, it's 50 there plus the 40 there for 90 degrees there. So that hasn't changed anything there. But PQS, from here to here to here, it looks like I would be taking this 90, P to Q, matching up with that central angle, another 90, so 180 for that part plus 50. So you could say 180 plus 50 as the most succinct way to show your work on that problem, 230 degrees for that. The measure of PRU, so connecting P to U through R, going the long way around, we could add up 90, 90, 50, 40, and 50, or more simply, we could just subtract 40 from 360. So that's the route I'm going to take with that, because what's left over would have to be what it would be from there to there, and that is 320 degrees. From there, let's take a look at number 14. I'll switch to blue here. Now we are still talking about this problem here, find x. We're using that picture still for this one, of the measure of PQR. So P to Q to R, that looks like a semicircle, 180. And I do want to put the arc symbol above that, so put that on yours if it's not there already. So we have 180 degrees would equal 8x minus 20. You can add 20 to both sides. And I'm just running out of space here, so let me put that here. 200 would equal 8x divided by 8. And you would have your answer of x equals 25. So 25 is the value for x on that one. Now we're looking at a problem that is separate from this picture. If the radius of a circle is 5 centimeters, what's the circumference? The circumference formula is 2 pi r. So 2 times pi times the radius, and the radius is 5, so that would become 10 pi. It says leave your answer in exact form or pi form, so that's how I would leave my answer. I'm not going to multiply by 3.14159. Not going to use that button on the calculator for this one. So we have 10 pi centimeters as my units, so I would include that here, and I'll write that on the line over here as well. Number 16, if the circumference is 80 feet, what is the diameter? So circumference is 2 pi r, but 2 times the radius is also the same as the diameter. So the more direct way to get diameter is use this formula instead, since 2r is the same thing as d. 2 radii is the same thing as 1 diameter. So you can plug in then 80 for circumference into this formula, divide by pi, and you should have your answer. Round to the nearest tenth, so 80 divided by pi. I would suggest that you have your calculator out as you're going through this. Make sure you're typing in these things yourself to verify that you can get the same answer with your calculator as what you see here. So it looks like this is 25.5 units per feet. This is just a length or a distance, so no squared, no cubed on that there. So just 25.5 feet. Now 17, if the radius of a circle is 14 meters, the measure of arc ABC is 250. Find the length, not the measure of the arc. We already know that. Find the length of arc ABC. Leave your answers in exact pi form. So the formula I had used was that arc length is going to be the portion out of 360, which I'm referring to that as x out of 360, times what the whole circumference would be. So it's the part of the whole circumference. That idea makes the most sense to me, so that's the way I teach it. If you had learned it in a proportion way, that works just as well to get to the final answer also. So up to you if you want to use this formula or the proportion way, but I'll show it this way here. So the measure of arc ABC, and just to give you a visual of maybe what this could look like, let's say this is A, let's say this is B, and this is C. So from here to here, it's 250 degrees. That would leave 110 for right here. But there to there is 250 degrees. So we're trying to find the length of this arc. Let me use a highlighter for that. We're trying to find the length of what this would be from there to there, given that this has a radius of 14 meters. So from there, I'm going to be looking at plugging in 250 in for this. So we've got 250 over 360 times 2 pi r, so times 2 pi times and then 14 for the radius. So then from there, it's saying exact form or pi form. We need to simplify that without putting it into a calculator. So these zeros here could cancel, be left with 25 over 36. I could multiply. I'm going to put this over 1 just to make it a fraction, to make it easier to think about multiplying those fractions straight across. So I would have 25 times 28 pi on the top, 25, and then 2 times 14 is 28. And then I have 36 times 1 on the bottom. So I'm continuing to simplify this fraction. I notice that 28 and 36, they're both even, and they're both also divisible by 4. So I could change this to a 7, divide it by 4 and get 7. I could change this to a 9. That's not my best looking 7 there. Let me make that a little clearer. So changing 28 to 7, changing 36 to 9. 25 only has factors of 1 and 5 besides itself. None of those are going to divide into 9. So it looks like this is fully simplified as much as it can be. If you had 7 quarters, it'd be $1.75. So we have 175 pi over 9 as a final answer. Looks like units were given, so this is meters. This is an arc length, not an area, not a volume, so I would just leave it like that. So you could write it like that, or you could write the pi after it. Make sure the pi is not with the bottom, though. So we have that as our final answer on this one. And then 18, if the diameter of a moon is 2,548 kilometers and it's orbiting a lunar station, is 32 kilometers above the lunar surface, find the distance traveled by the lunar station in one orbit. So we've got this moon. Could be Earth's moon, could be a different moon. I don't think that our moon has a diameter of that, but I'm not totally sure. I'd have to look that up. But we're saying the diameter of that all the way across is 2,548 kilometers. And then we've got this orbiting lunar station. So I'm going to draw that in, I'll go with purple here. So orbiting this moon in purple is this lunar station. That was a decent circle for a freehand one on this program. I'm pleased with that. So it's circling 32 kilometers above the lunar surface. So from here to here, a distance from here to here would be 32 kilometers. This was the diameter right here. So that means the radius, when I do that in orange, the radius of the moon would be 2548 divided by 2. 2548 divided by 2 is 1274. So you'd have that many kilometers for your radius. So from here to here, that orange part would be 1274. And so if we're trying to find the distance traveled by the lunar station in one orbit, we really could just look at this radius, orange plus purple. That's the radius of the lunar orbit, and then find the circumference of that whole thing. That's what we'd be doing to figure this out in the end. So the circumference of the lunar orbit, is going to be equivalent to the distance traveled by the lunar station in one orbit. So we've got 2 pi r for that. So it's going to be 2 times pi times, and then the radius would be 32 plus that 1274, which is the radius of the whole moon. So then from there, let's calculate what we have. And it doesn't say to leave it in pi form or decimal form. So from here, I'm going to get both forms. Why don't I just do it that way? So 2 pi times, and then 1274 plus 32, we'd have 1306. And if you multiply 1306 times 2, you multiply that together, you get 2612 pi kilometers. So you could see an answer like that, or you could round that off. And let me double check. I'm doing this the same way as I've done other reviews in the past year. I've got a key next to me that I've either worked through myself or another teacher has done, but then I'm going through it fresh here and then double checking mine against the key as I go. So the key I had posted, if you're one of my students on my class webpage, said 8205.6, but the answer I'm getting here, best answer 8205.84, so rounded off to 0.8. So I would say this is our best approximation, and it does say to draw a figure too, so we have that figure done there. So 8205.8 kilometers, rounded to the nearest tenth, best answer I think you could get on this one here. Let's take a look now at number 19 through 24 will be on this slide. I see a lot of right triangles for those first three, so Pythagorean Theorem looks like it might be coming into play for these ones. Let's take a look at 19. So we've got, assume that the lines that appear to be tangent are tangent. That's pretty important on this one here. So this looks like it's tangent, so you can make that assumption that it is, and if something is tangent, a line is tangent to a circle or a segment is tangent to a circle, that means it's perpendicular. That was a theorem that we discussed earlier. So this is 3 for radius. This is 7 from T to S. So at first it seems like you don't have enough information to figure out what RS is using the Pythagorean theorem, but recall that this is also a radius, making that 3. Or take a look and observe that, make that observation. So we have then 3 squared, leg squared, plus RS would be the other leg. So I'm going to just call that RS, leave it like that. If you wanted to call it X, just make sure you label it with an X or whatever variable you want to use. And then that should equal your hypotenuse squared, so 3 plus 7 squared. This would be 9 plus RS squared equals, and then that would become 10, and 10 squared is 100. So then you subtract 9 from both sides and you have 91, and then take the square root of both sides. That's not saying to have exact or approximate form here, so I'll include both. So you could say the square root of 91, and that is approximately to the nearest tenth 9.539, so round it off to 9.5 on that one. On this problem, OK is 5, KL is unknown, that's what we're trying to figure out, but from here to here is 3. So it looks like we could figure out what this is. And then one of the theorems that we learned in this chapter was that if you have a radius or diameter that's perpendicular to a chord, which if you extended this right here all the way, it would be a radius that's perpendicular to a chord, then that means it bisects the chord. So this is congruent to this. Whatever we find out this is, we would just double that to get what KL is. So it looks like we've got 3 squared plus x squared would equal 5 squared on this one. That'd be 9 plus x squared equals 25. You could subtract 9 and get x squared is 16, and then take the square root of both sides to get that x equals 4. So then KL from there, rewrite that KL is going to be 2 times x, which is 2 times 4, which is just 8 from there. So KL should be 8. Number 21, we're looking at, for CK, that's 30 degrees, that arc. So that means this arc is also going to be 30 degrees, or this angle, sorry, the central angle is also going to be 30 degrees. If that's 90, this is 90, and that makes this angle right here 60. So we've got a 30, 60, 90 triangle right here. It tells us that AK as well is H right here. So I'm going to label that with an 8. So I'm going to draw this triangle again, this OAK off to the side. And this is 8 here. And this is 30. And this is 60. And we've got Then our 30, 60, 90 ratios, the leg across from the 30 was a short leg. We called that n in class. And then the 60 across from that is a long leg. That was n root 3. And then this right here is the hypotenuse to n. And in this problem, the hypotenuse is what we care about because that is a radius. And if we knew the radius, SC is a diameter, we would just double the length of the radius. So if 8 equals n, that means 2n equals 2 times 8. So 8 equals n right there is clear. That means that 16 is that, which is the radius. And so to get SC, which is just a diameter for that, we would just do 16 times 2, which would be 32. Moving on to number 22 then, it looks like we have two rays that are tangent to this circle. A theorem that we learned in this chapter was that anything where you start at the same exterior point and have two tangents to a circle, from that, those two segments created by those tangents, so from the tangent point to the exterior point to the exterior point, are congruent. So we could say 62 equals 7x minus 8. You can add 8 to both sides and get this, and then divide by 7, and you'd get x equals 10. So your answer there should be x equals 10. I suppose I should write this in for those that find it helpful. So we have then on this one now it's looking a little different than what we had so far. This was a different theorem that we learned. This being 100 degrees right there means that this would be 260 degrees from, well, from here to here would be 260 degrees. So then if we've got 60 of those degrees here, that means this arc from that dot to that dot would be 200. So 200, that's just coming from 360 minus 100 minus 60. So 200 degrees is that arc from that dot to that dot right there. And so this problem was a problem where you're supposed to be doing, when you have a secant and a tangent or two secants, you look at the big arc and the small arc, you subtract the two and take half of that. So we're doing 1/2 of the big arc minus the small arc to get our answer on this. That's what x would equal. So the big idea, if you have it in your notes, if you're one of my students, we had some pretty thorough notes for that stuff. The big idea was 1/2 of the big arc minus the small arc. So we've got 1/2 of 140 then in that case, and that is equal to 70 degrees. So 70 degrees is x right there. Hexagon without an O is a regular hexagon. Measure of HE, arc HE, would be what then? If this is a regular hexagon, that means it splits it up into 6 equal parts here. So we could find the measure of this angle by just doing 360 divided by 6, which is 60, and the central angles are always going to match up with the arcs that they intercept. So we have 60 degrees for that right there. Just need to see that 360 divided by 60 work somewhere for that one. Looking then to, and I've left a little space up here and down here just to give me a little room to show work. Hopefully you can find some space on your paper to show work if you had printed this out. So we've got x here. 5 is from here to here. I think that's maybe a little bit unclear, but it's right in the middle of that segment. So 5 is there to there, x is here to here. And we've got a radius that's perpendicular to a chord right here. So if we're calling that x, this would also be x. I'm not sure if that'll be helpful or not yet, but it may be. And then we have 12 for a radius. So the trick, or the observation you need to make on this one is that would be just another radius right there, which would be 12. And so we've got 12 there. And so would this right here. This would be another radius. That would be 12. And so I was thinking I'm going to need to do some Pythagorean theorem work here, which is true. This segment from, and I'll draw this in red. So the red part right there, from there to there, you're going to have 12 squared, the hypotenuse squared, is equal to leg squared plus leg squared. So this right here would just be 12 minus 5, which would equal 7. So that's that length from there to there. Since from here to here is a radius, 5 of it is here, 12 minus 5 would give you your leftover part there. So your hypotenuse squared would equal 7 squared plus x squared. And so from there, it looks like we'd have 144 equals 49 plus x squared. You could subtract 49, and you'd be left with 95 equals x squared. 95 is just 5 times 19. Both of those are prime numbers, so no pairs that would come out of there. If you're doing a factor tree sort of thing, this would be an exact answer already in simplified radical form if you were asked for the answer in an exact form. So x is square root of 95. If you were asked for the answer in an approximate form, just put that into a calculator. And 9.7 and some change, so about 9.7 times itself would be 95. So that's rounded off to the nearest tenth. 9.74679 to 5 decimal places is what I had there. On JL, on this one, JL is what we're trying to figure out, which looks like it is a diameter. We're told that this is 4, and if that's congruent to that, that means this side, KL, would be congruent to this side, KJ. So then another thing you could assume on this one, anytime we have an inscribed angle that intercepts a diameter, that was a 90-degree angle, and if these are congruent then to each other, that's a 45, 45, 90 triangle. So all that said, knowing that it's 45, 45, 90, this is n, this is also n, and then this is n root 2. N equals 4 right there, so that means this would be 4 root 2 right there. So we've got 4 root 2 is what JL would be. And then the exact circumference. Circumference is just either 2 pi r or pi d. Since we have d, we have the diameter, we would just be taking pi times 4 root 2. And the most appropriate way to write that in an exact form would be 4 times pi, then times the square root of 2. We wouldn't want there to be any ambiguity as to if you had put the pi after it, is the pi under the square root, is it not under the square root? That's the appropriate way to write it so that there's no uncertainty about that. So 4 pi times the square root of 2 for the exact form. 27. X, it looks like, is the whole length of this chord. 7 is the length of this segment right here. 25, it appears to be a radius right there. So on this one, it looks like we could draw this in right here. Let me use blue for this. So this segment, I'm trying to freehand. When I use my straight edge tool on this, when I'm making a video, it's only when I'm making a video, it like jumps all around or it looks really weird. So there we go. That's better. So that's 25 also right there, if that's because that's just another radius. So you have 25 for your hypotenuse of this right triangle, and then this could be called x divided by 2 right here, or I think more simply I'm just going to call that y and y. So I'm going to say 2 y's make up an x. So initially I'm going to say y squared plus 7 squared equals 25 squared. And we can say that these are the same because you have a radius. If you extend that, that's perpendicular to a chord. That was a theorem we learned. So we have y squared plus 7 squared is 25 squared. Y squared plus 49 then would be 625. If you subtract 49 from both sides, you're left with 576. So y squared is 576, and then take the square root of both sides, and you have what y is. Y would equal 24, and so that means x, which is 2 times y, would equal 2 times 24, which is 48. So that would be your final answer on that one. 28, looks like we have 30 degrees here, 45 here, x there. This x is the unknown. The formula was that the angle measure, which is 45 in this case, the angle on the exterior of the circle was equal to 1/2 of the big arc minus the small arc. So we do 1/2 of x, the big arc, minus 30, the small arc that it intercepts. And then we just need to solve that for x. To me, the easiest way to approach this is take both sides and just multiply them by 2. By doing that, the 1/2 and the 2 here are going to cancel. This is really just 3 things multiplied together. 1/2 times whatever x minus 30 is times 2. So I can change the order in which I'm multiplying things, take 1/2 of 2, that's 1, so that cancels. So you're left with 90 equals x minus 30, and then you can just add 30 to both sides to get your final answer. With all of these, whenever possible, with any math problems, whenever possible, plug in your answer and see if it works. So you could take 120, plug that back in up here. 1/2 of 120 minus 30 would be 1/2 of 90, which is 45, which we started with right there. So that makes sense. On this one, this is a little sneaky here. When we had things intersecting, lines, secants, segments, whatever they may be intersecting on the interior of a circle, it was that the angle plus its vertical angle was the average of the two intercepted arcs. But if it's not, like, we don't know what this is and this is, so I think it's easier to call this angle 1 initially on this one, figure out what 1 is, and then do 180 minus the measure of angle 1 to get the measure of angle 2. So that's what I'm going to do here to start. Well, measure of angle 1 would be the average of the intercepted arcs, that angle, angle 1, and its vertical angle right there. So we've got 48 plus 38, half of that. So that would be 1/2 of 86, which would be 43 degrees. So that's the measure of angle 1. So the measure of angle 2 would just be 180 minus that. 180 minus 43, which is 137. We've got 137 degrees right there. This one, number 30, it looks like we've got a tangent and a secant here. We've got, in those problems, it's supposed to be 1/2. It's kind of like an inscribed angle. The vertex is on the circle. The formula ends up being the same as what it is for an inscribed angle. It's 1/2 of the intercepted arc. So if this is 228, this right here would be 360 minus 228, which is 132. So we're going to use that as this arc's measurement right there from M to N, the short way. And then to find the measure of angle 6, the formula is just 1/2 of the intercepted arc for problems like this. So 1/2 of 132 ends up being 66. 66 is your answer for that one, 66 degrees for number 30. If you're following along with a printed out packet, one of my students in class, we're on page 3 now. We're looking at number 30. Did I skip a page? Yep, I need to insert something in here. Just a second. And boom, like magic, there it is. I'm grateful to have the ability to pause the recordings of my videos. I do these in one take, but I have that chance to pause them if I need to. So there we are. There's 31, 32, and 33. Sorry, that wasn't in there before. So looking at then BF, I think that's just a stray mark. Ignore that little mark right there. And we're looking at BF would be this tiny little segment from there to there. The radii of circle F and circle G are 5 and 6 units respectively. So circle F is the center. The center of this circle is F if it's called circle F. The center of this circle is G if it's called circle G. And respectively, it just means G goes with the second one. The second circle with the second number, first with the first. So we have from here, F to G would be 5. From here, G to C would be 6. And then from F to A, from there to there, would also be 5. And from B to G would be 6. That's just the radius of this bigger circle. So to find BF, that looks like it would just be 6 minus 5, which would be 1 unit. No units given, so you could just say 1 or the word unit after that. 32, AB, it looks like if BF is 1 and F to A is 5, we would just be doing 4 minus, or not, I'm sorry, I'm thinking of the answer already. 5 minus 1, which is 4 in that case. And then for number 33, find X, then find the perimeter. So X, it looks like we've got a lot of exterior points that are tangent to circles if we connect the exterior points to the circles there. So tangent, just touching. all over this one, we could say this is congruent to this, this is congruent to this. This was a theorem we had learned that the segments from those exterior points to the tangent points are all congruent to each other. And so this one's congruent to this one. So that said, it looks like if this is 6, that means this side would be 6 right there, making this side 13 minus 6, which is 7. We've got 7 for that right there, and if that's 7, this is 7. And if that's 7, so is this, because that would just be 14 minus 7. And then if that is 7 right here, that makes this equal to 7 right there. So we have that x equals 7 on this one, and then the perimeter, a few ways you could approach that. You could do 18 plus 7 plus 7 plus 7 plus 7 plus 6 plus 6 plus 18. That'd be the longest way, I think, to do that one. Or you could just do the 14 plus 13 that was given to you originally, and then it looks like we've got 7, and then we have 18 twice, so I'm going to do 2 times 18 here and here, and then plus another 6. A little bit shorter to do it that way, but just adding everything up. So you've got 27, 34, 34 plus 36 would be 70, and then that plus 6 would be 76. So 76, no units given, you could just write 76 as your answer on that one. Number 34 then, it looks like we've got an angle, we've got lines crossing on the inside, or segments crossing on the inside of a circle. The formula was the angle itself was equal to half of the, or the average rather, of the intercepted arc. So x plus 80. My personal preference is to take something like this, get rid of that 1/2. It's really like dividing by 1/2, which is the same as multiplying by 2. And that would get the 1/2 and the 2 to cancel. You'd be left with 110 equals x plus 80. I'm saying that rather than distribute the 1/2. I think you totally could do it that way, but it would just take longer, be some unnecessary work. We can subtract 80 from both sides then and get 30 is equal to x. Number 35, we're looking at the angle is going to equal 1/2 of the big arc minus a small arc. So the angle x is going to be equal to 1/2 of the big arc. If that's 125 from here to here, this would be 360 minus 125, which would be 235. So we have 235 for this arc from there to there, the longer way around. So we've got 1/2 of 235 minus 125. When they're intersecting on the outside of the circle, we subtract instead of adding. So it's 1/2 of the big arc minus a small arc. That'd be 1/2 of 110, which would end up being 55 on that one. So we have 55 degrees for the value of x in that problem. 30 degrees. If you left the degree measure off here, I think I'd be okay with that. At least myself, I'm picky about units, but I'm not picky about degrees typically. So we've got 4x minus 5, the measure of an inscribed angle. Comparing that to the intercepted arc, central angles match up exactly. Inscribed angles were half. So if we took 1/2 of 30, that should equal the inscribed angle, which is 4x minus 5. So 1/2 of 130, I think I said 30, 130 is 4x minus 5. So 4x minus 5 would equal 65. Add 5 to both sides, then divide by 4, and you should have what x is. So it looks like 4x equals 70, and then we can divide by 4. Doesn't work out as an integer value on this one, but you could write it as a decimal, 17.5 as a fraction, 17 and 1/2 mixed number style, or 35 halves as an improper fraction. So we have 17.5, that's the answer I'll use here, but again, 35 over 2 would work, and 17.5 would also work. Number 37, we've got another problem where you have exterior points. The segments from those exterior points to 2 tangents on the circle are congruent. So that's congruent to that, that's congruent to that, and this is congruent to this. If we're trying to find what x is, it looks like if that's 7, this is 7, this is 3, this is 3. I'm thinking about perimeter in advance, so I've got all that stuff once we know what x is, and we can plug it in to figure out what the whole perimeter is and figure out this problem in its entirety. So we have 2x plus 5 is equal to 4x minus 3. If you subtract 2x from both sides, and I'll do this in the same line here, I'll add 3 to both sides as well because I know this is going to cancel and get the x's on the right side, and then I'll move the regular numbers to the left side. I say regular numbers, that's not a very technical term, but the numbers without variables attached to them. So we have 4 equals x for the value of x, and then from there we could take this, plug it in, and I could figure out either one of these. 2x plus 5 would be 2 times 4 plus 5. My 4s are looking like 9s sometimes, sorry. 2 times 4 plus 5 would be 13 there. You could do the same thing here. I'm going to do it just to double check that I didn't make any mistakes. So 16 minus 3 is 13 as well. Those being equal to each other is a good thing because they're supposed to be. If that number did not equal that number when I plugged it in, I know I would have done something wrong. And then finally here, perimeter is going to be all those things added up. So I have 2 13s, I have 2 7s, and I have 2 3s. So I'm just going to write it like that. Well, that would be 26 plus 14 is 40 plus 6 there would be 46 for your final answer for number 37. 46, no units given, so you can just write 46. On this one, it looks like we have a diameter here. Anytime we have a diameter and an inscribed angle that's intercepting that diameter, we know that this is a 90-degree angle right here. And if we know that's 90, that could help us figure out this problem. We've got 180 from there to there, so this arc would be 100, which is just 180 minus 80. And if that's the case, x, we could use this value right there. I could have figured out, I don't know that I even needed to know this. Thinking through that now. So x would be 1/2 of 110. This, if I called it y, something like that, y would be 1/2 of 80. Inscribed angles are half of their intercepted arcs. I don't know that I really needed to know that, but that's valuable to know or to review at least. So x would be 1/2 of its intercepted arc, so this angle intercepts this 100-degree arc, so we'd say 1/2 of 100, which is 50 degrees. So we've got 50 degrees on this one. From there, we have this one here. We have an inscribed angle here. I'll call this the blue one. 3x minus 12 is intercepting arc RS, and angle T right here, which is 5x degrees, is intercepting the same arc. Both of those angles are intercepting this arc RS right here. So if we have two angles intercepting the same arc, they are congruent to each other. That was a theorem we learned in this chapter. So you would say 3x plus 12 is equal to 5x. You could subtract 3x from both sides. You have 12 equals 2x, and then divide by 2 to get your answer of x equals 6. And then it's the last page for those that are in my class or one of the other teachers' classes from school I teach at. We're looking at this one. This one, it's a doozy. It looks like a really, really challenging problem. There's a lot to it, but if you take it one little piece at a time, this will be a much easier problem than it initially appears to be. So we have a diameter here. My approach, or my strongly encouraged advice, is to find all the arc pieces first before you do any other calculations or try to figure any of this thing out. Don't even worry about what's over here on the left for right now. Let's just figure out the missing arc pieces around the circle. So it looks like I'm missing GH, I'm missing HD, and I'm missing AB. This BD is a diameter. So this would be from here to here 180 degrees. I've got every single other piece, and so I could figure this out by doing 180 minus those three other pieces. So minus 56, or subtract 56, 18, and 42. Subtract that all from 180. So if I do that, and I'm just going to use my calculator to double check my mental math. Yep, so 64 degrees right there for that arc from A to B. And from here to here would also be 180. But I only have this part, so I would need to know either this part or this part to figure out the other missing piece. But this is 90 degrees right there. Central angle is always going to match up with the arc that goes with it, or the intercepted arc, the arc that it intercepts itself. So that's 90 degrees right there. Now this would be, if that's 90 degrees right there, this would also be 90 degrees. So I could do 180 minus 90 minus 38 to get what GH is, or I could just do 90 minus 38 since I know this whole thing is 90 from here to here. And for that, that would leave me with 52 degrees. So this is 90 minus 38. And so from there, AB, we already figured it out. We did the work for it here. You may have a different approach that you used or plan to use on a problem like this. You may have a different way to get to the same answers. The way I'm showing you is just one way to do this, but whatever way you do it, you should get the same answers with all of these problems. There should be, like math is logical, sometimes there's more than one route to get to the final answer, but in the end, we all should get the same things. GH, we already figured out. I showed the work for that, 52 on that one. Measure of DH, and we already got that as well. That was a 90-degree angle. Central angles are congruent or equal in measure to their intercepted arc, so 90 degrees right there. The measure of angle 1, it looks like this is a right angle because this is a diameter. So this is an inscribed angle that intercepts a diameter. That was a theorem that we learned as a shortcut. So this would be 90 degrees. I would take that without any work needed on that one. Angle 2, it looks like the measure of angle 2, this would be, it's intercepting this arc right here, 42, 18, and 56 put together, and it's an inscribed angle. So it would be 1/2 of the sum of those angles, 1/2 of 56 plus 18 plus 42. Looks like that would be 1/2 of 116, and 1/2 of 116 is 58. So we'd have 58 degrees for that one. Measure of angle 3, right here, a similar process can be used for that. It's an inscribed angle. So it's an angle with its vertex on the circle. It's going to be 1/2 of its intercepted arc, 1/2 of 64, which is 32. And something interesting to note here, if this is 32 degrees right here, and this is 58 degrees right there, and I think I'll write those in case I want to make use of those values later on, and this was 90 degrees right here, you could take that plus that and plus that, make sure they add to 180. They do, but if they didn't, then you probably did something wrong, and you need to, or you definitely did something wrong, and you need to go back and try to figure out where you went wrong. The measure of angle 4, there it is. I was having trouble seeing it. Where was that? But it's going to be one of those 1/2 of the big arc minus small arc problems. So the measure of angle 4, I'll do that work in purple over here. So the measure of angle 4 is 1/2 of its big intercepted arc is 52 minus its smaller intercepted arc is 18. So the measure of angle 4 would be 1/2 of 34, which is 17 degrees. So the measure of angle 4, 17 degrees for that one. I'll write that in here next to that. The measure of angle 5, looks like this is one where it's intersecting on the inside of the circle. So I'll do that work up here for that one. So intersecting on the inside, we're doing 1/2 of the angle's intercepted arc and its vertical angle's intercepted arc. So it would be 1/2 of 38 plus, and then the angle, that's that one, its intercepted, its vertical angle's intercepted arc would be 18 plus 42. So this angle cuts through that arc right there. This angle cuts through that arc right there. So we've got, to this would be adding this 18 plus 42, which is 60-degree angle. So 1/2 of 38 plus 60 would be 1/2 of 98, which is 49 degrees for the measure of angle 5. 49 degrees right there. So I'll write that next to that. Angle 6 we already determined was 90, so no work needed there. It was just 180 minus the 90 there. I don't need to see work for that. Number 7, or angle 7, looks like, what would be the easiest way? Probably doing it this sort of way. Again, angle 7 is this angle right here. It intercepts arc G to D the short way, G through H and D, and then its vertical angle is going to intercept 56. So I'm going to take that approach. If you had a different approach that worked, that'd be just fine. Just make sure it matches up in value with what you see here. So 1/2 of the angle's intercepted arc would be 90 plus 52 right here. And then its vertical angle's intercepted arc is 56. So half of those two things, this would be 142 right there, and then plus 56 would be 200. So half of 200 is 100 degrees. I'm messing that up. I'm thinking, wait a minute, that doesn't seem right. Comparing it to my other key, that's 142, but plus 56 would be 198. Sorry about that. That would be 99 degrees then. So 99 degrees right there. Measure of angle 8. I'm going to keep using that 1/2 of the intercepted arcs approach as I wrap this one up. Why don't I use orange for these last 3 just to make it a little easier to follow along, I hope, with what's going on here. So 8 is that one. Its vertical angle is that one. 8 would go through this arc right here. It would intercept A to H going that way. So 64, 38, and 52, if we add that together. 64, 38, and 52. That's the measure of the arc that angle 8 intercepts, if you extend that out this way. And then its vertical angle would intercept 42. So we have 1/2 of all that put together. 64 plus 38 plus 52 plus 42 is 196. So 1/2 of 196 ends up being what I'll write right here, 98 degrees. The measure of angle 9 looks like another instance where I could use that same idea, 1/2 of the intercepted arcs with respect to the angle and its vertical angle. So measure of angle 9, 1/2 of, and then this cuts through 90 degrees right there, so 1/2 of 90, and then its vertical angle right here would cut through 64, 56, and 18, the sum of that. So 64 plus 56 plus 18. And looks like that all put together would be 228. So we're taking half of 228, and that is 114 degrees. And then finally, the measure of angle 10. 10 is, it's not exactly an inscribed angle because it's a tangent and a secant rather than two secants, but it's the same formula as the inscribed angle, so it's just half of its intercepted arc. So half of angle 10, if you're looking at that, it cuts through from E and then wrap it around back to G. So 18 plus 42 plus 90 plus 52. I'm taking the sum of those and taking half of that. 18 plus 42 plus 90 plus 52. That's going to be 1/2 of 142, 184, and 94. One is 202. So 1/2 of 202 is 101 degrees. And I'm double checking this, all of these against the key that had been pre-worked out by another teacher in this instance. And what I see matches up with what's there. So good to go. What you see on the key that's posted online, if you're one of my students, the handwritten one might look a little bit different in terms of the approach taken for figuring these out, but that's what we have on that one. Those are the right answers for that. And again, just a recap of this, there's just a lot to it, but if you find those missing arcs first, that's, I think, by far the easiest way to do this. Do that first and then tackle all these missing angles from there. To wrap things up, we've got 5 more problems dealing with equations for circles, the equation for any circle, if you use this formula, or you really need to know this formula to be able to be successful on these types of problems. So x minus h squared, y minus k squared is r squared. hk in an equation like this is your center, and r is your radius. So the radius is r. The equation has r squared in it. Notice also the equation has a minus sign here and here in it, so it's always going to be the opposite of what you see here for your center points. So with that said, the center at the origin, the radius is 6. Origin would always be y minus, and I'll do the work in a sense underneath here, and then I'll write the simplified answer of that right there. So y, I should do x minus 0 first there, sorry, plus y minus 0, since the origin is at 0, 0. And the radius is 6, so 6 squared. So the simplified version of this would be x squared plus y squared equals 36. That would be your final answer on that one. On this one, if your center is at 4, -3, this is your h, this is your k. And the same thing will apply here on this one. That's your h, that's your k. This would be x minus 4 squared plus y minus -3 squared equals 9 squared. So to simplify that, x minus 4 wouldn't change, but then y minus -3 could be written as y plus 3 squared. If you wanted to go straight to that, you just recognize it's always the opposite sign of what you have with the numbers. That's fine. And then 81 is your radius squared. And then here, center is at hk, we'd have x minus -7 squared plus y minus 1 squared equals, and the diameter of 24 means the radius would be half of that. The radius would equal 2. 2? What am I saying? 12. I wrote down 12 where I wanted to write 2, and I wrote down 2 where I wanted to write 12. There we go. 12 divided by 2, you get 12. So the radius is 12, so you're squaring 12. And so you've got x plus 7 squared plus y minus 1 squared is 144 on that one. And finally, number 56, 57, for each circle with a given equation, state the coordinates of the center and the measure of the radius, and graph the equation. So we have here x squared plus y squared equals 16. The center would be what, and the radius would be what. So this looks like it's a version, or it looks like it's the same as x minus 0 squared plus y minus 0 squared equals, and then 16 is the same thing as 4 squared. So if you want to find the radius, you can always just take the square root of that, as long as this is in an x minus h squared plus y minus k squared equals r squared form, which it is here. So the square root of 16 is 4, and so you'd have 0, 0 as your center. Your radius would be 4. We're graphing the equation. I'm going to have to do a freehand sketch here since my tools don't like it when I'm making a video for whatever reason. So 0, 0 is the center. Your radius is 4, so from there I'm going to go out 4 in each direction, vertical, horizontal from that point, and then I'm going to do my best with this with this tablet to draw a freehand circle. So as long as, if you're one of my students at least, as long as your circle looks decent, it doesn't look like this, it doesn't look like it's got polygonal sides, so don't do that. As long as you attempt to make a decent looking circle, you would be good to go on questions like that. So then on this one, looks like we've got both of these. Remember, this is your HK is the thing that comes after the minus sign. So both of these being x minus and y minus, both have minus signs. That means your h is equal to +1, the opposite of the value you see there, and your k is equal to +1, or +4 in this case, as well, both of those being positive. If there was a plus sign on one of those, we'd have to make one of those negative, the corresponding one negative. And then r is going to be the square root of whatever you see there. So r is a square root of 9 in this instance. that means r would equal 3. So we've got our h, we've got our k, we've got 1 and 4, radius is 3, 1, 4 would be our center point right there, and then go 3 in each, I want to say cardinal direction, is that right? Cardinal direction, horizontal, vertical direction, up and down, left and right from there, and then draw your best sketch from there of the circle. I'm feeling decent. That's not bad. No, that could be better. Let's connect that there. Yeah, it could be better, but that's the idea. We've got a circle centered at 1, 4 with a radius of 3. Looks like that does it for this. So if you're one of my students, we were going to take this test right before school shut down, or right after school shut down, I should say. We had the whole week, we had done the chapter review, and then you're going to take that test the following Monday, but then that didn't happen. School was shut down. We started to do remote learning, and so this, I hope, is a good recap for you. Hopefully you found something valuable in here as you worked your way back through this. It was good for me to review this stuff too, going through this. It's been a little while since I've thought about circle equations like this, but it came back to me. It's kind of like riding a bike, I think. Excuse me. But if you have any questions, if you're one of my students, feel free to send me an email. If you are not one of my students, feel free to comment, and I'll try to get back to you on those comments as well. Hope you found it useful, helpful. Hopefully you can find some practical applications for this in life beyond geometry as well, because there are many out there, and I hope you have a great rest of your day. Catch you later.